So the question that we have here is a previous year question from GATE 2021. It's a beautifully framed question, so let's solve. So it is given that two mild steel plates of similar thickness in butt joint configuration are welded by a gas tungsten arc welding GTAW process using the following welding parameters. So the welding parameters are welding voltage is 20 volts, welding current is 150 amperes, welding speed is 5 mm per second. Okay. Next, a filler wire of same mild steel material, okay, having 3 mm diameter is used in this welding process. The filler wire feed rate is selected such that final weld bead is composed of 60% volume of filler and 40% of the plate material. Okay. The heat required to melt the mild steel material is 10 joule per mm cube. Next, the heat transfer factor is 0.7 and melting factor is 0.6. We need to find the feed rate of the filler wire in mm per second. Okay. So before we start the question, I guess you all know what a gas tungsten arc welding process is. So assuming you have some basic knowledge about that, let's proceed with the question. So the given electrical energy from the welding machine we can calculate as voltage into current, that is the energy that is supplied due to the electrical source, power source. But that energy is not completely transferred to the material for welding. No, there will be some losses. So that loss is given in terms of factors, heat transfer factor and melting factor. So that electrical energy is first multiplied with the heat transfer factor. So that much of amount of energy is first reaching the material to be welded. And from that energy, only 0.6%, only that is 60% of that energy is used for welding. Rest of the energy is like going to the heat affected zone or heat affected zone. Like it is not contributed to welding, but it is just spreading to the other parts of the material. So by this equation, we can find the actual heat that is supplied to the weld process, that is 20 into 150 into 0.7 into 0.6, that we have as 1260 watts. Next, from the question, they are given for the welding process, for 1 mm cube of volume, we need 10 joules of energy. So from that, we can actually find the heat required for the welding process, which is energy density, which is 10 joule per mm cube into area of that weld cross section into the speed of welding. They are given the speed for welding as 5 mm per second. So from this we can find area of cross section. So by equating both, that is 160 is equal to 50 times area, we can find the area as 25.2 mm square. Okay. So from this we can find the volume or volume flow rate, since we are measuring in a particular time frame, we are having volume flow rate, that is 25.2 into 5, that is 126 mm cube per second. Okay. So next, the key part from this question is they are asking the feed rate of the filler wire. Okay. Here it is what do you say? They are given feed rate of the filler wire, that is 6, and it is given that 60% of volume of that weld is made up of filler wire. So filler wire is actually melting. It is a consumable electrode of a consumable filler welding process, as you can see. So 60% of volume of filler is from the total volume, 60% is made up of filler wire. So multiplying 0.6 with the total volume that you have 126, we will be having 75.6 mm cube per second. So from this, I think you can proceed. It is easy. Next is the easy step. So we have 75.6 mm cube per second, and we have the diameter of the filler wire as well, which is 3 mm. So multiplying the area of cross section into feed rate, we will be having 75.6. So feed rate can be calculated, and it is found to be 10.69 mm per second. Since it is given in the question to round off to 1 decimal places, the final answer is 10.7 mm per second. So yeah, it's an easy question actually.